Welcome and thank you so much for joining me today. So a planar graph is drawn with no edges intersecting except at vertices. So right here we can see all these edges are not intercepting. Whereas a non-planar graph is when they are intercepting. So, but not all graphs are planar graphs, which we can see here. But some of them are able to be redrawn as equivalent. And we have looked at equivalent isomorphic planar graphs before. And an isomorphic graph is a graph that is the same. So that means it's got the same amount of vertices, edges, and degrees for each vertex. So let's have a look at this. At the moment we've got two of our edges that are intersecting from A to E and 2D to A. I'm going to move this one from C to E, and that's going to make it a lot easier for me. So when I'm redoing my graph to change it to planar, I need to make sure I've got my same amount of vertices. I've got my A, B, C, D, E, and F. I'm going to draw my edges in. I've got all my edges at the moment, the ones I want, and I will just label my drawing now. So we've got A, B, C, D, E, and F. So the first thing I would like to think about is I am going to move my C to E line above. As soon as I have done that, I can still have my A to D line and nothing is overlapping. There is no intersections, which means I've turned it into a planar graph. Let's look at a few others, and this is where I encourage you to pause the video and have a go yourself. So we have to redraw each of these graphs to be an equivalent planar graph. So I'm first going to be thinking about, I've got my 4 vertices, A, B, C, and D. Now I need to be thinking about how I'm going to move them. So I'm going to keep most of them the same. It's only at this stage one I'm going to move, which is my line from A to C. All I'm going to do is, instead of cutting it through, I'm going to go around. And I've created an equivalent planar graph. Okay, let's look at B. B is the exact same. I can see that I've got one line. Either I can do C or B, or I can move A or D. If I take that and put it around the outside, it's not intersecting, so it will be a planar graph, and it will be isomorphic because it will be the exact same as what I have. So again, I just make sure I put down my vertices, A, C, B, and D. I'm drawing my A to C, C to D, D to B, and B to A. I'll keep my line from A to 2D, but my line from C to B will go on the outside. It's exactly the same thing with C. I only have to move one of my lines. I can move either E to B, or I could move A to C. So for me, I'll just keep a copy of this time. I'm going to take away this line here from A to C, and I'm going to replace it with a line around the outside, A to C. D looks a bit more complex, but it's not that hard. We just need to break it down and think about it. So at the moment, we've got a few lines that are intersecting. There's an intersect here and an intersect here. We need to get rid of those intersects. To do that, I'm going to think about it as a big rectangle and a smaller rectangle in the middle. So this is where we need to understand the shape to be able to help us and make it easier. So I'm going to have a vertice here, and again on each of the corners on the outside. Now all I've done, I've still got my prism, but I've literally just put my A here, my B here, so this is my top, my E, and my F. And then my bigger rectangle, I've got the bottom of my shape, my D, my C, my G, and my H. Now, the only X's I haven't put in is the ones that are connecting the bottom of my shape and the top. So I've got a X from A to D, an X from B to C, an X from F to G, and an X from E to H. And there we have it. We have our equivalent isomorphic planar graph.